There have been several attempts to rectify the situation. The first attempt to shelter Venice from the waves was made soon after its settlement, when crude breakwaters were constructed as shields against the waves of the Adriatic Sea. A project expanding these ancient barriers was begun in 2003. Boulders form a strong foundation, and the addition of acropoles, jigsaw-like concrete blocks, form the final reinforcement. The acropoles are moved via cranes mounted on barges and are guided into place by scuba divers. The overall system stretches over 6 kilometers, barring the entrance to the lagoon, except for small inlets. As part of the modern effort to understand the flood patterns, Venetian engineers constructed a full-scale model of the lagoon. Major flood patterns are determined by increasing the water level within the scale model and observing the movement along the scale lagoon planes. More detailed assessments were made using a wave tank, producing waves to scale with the actual tides. This level of detail was necessary for a more technical solution. Also in 2003, construction began on the Modulo Sperimentale Elettromeccanico, or MOES for short. This massive system employs rows of massive hydraulic gates arrayed along the lagoon floor. When the tidal effects are predicted to be particularly detrimental, compressed air is pumped into the hollow compartments within the barriers. Buoyant forces causes these to rise and block the flow of tidal current. When the water subsides, the barriers are allowed to sink back into the bottom. This system is to be implemented in the 3 main inlets of the Venetian lagoon. The last solution to be covered takes the form of a promising and relatively new technology called protocells. Protocells are oil droplets that can be programmed to produce a carbonate shell. In order to strengthen the wooden piles, protocells will be injected into the canals. As they are light sensitive, they will travel towards the darker regions in the water where the foundation of buildings are found. Once there, the presence of water and the accretion of tiny marine organisms will provide an ideal environment for the protocells to secrete a limestone-like substance around the wooden piles. The protocells can be chemically engineered to follow certain chemical gradients and move around beneath the environment. The end result? A limestone reef underneath the city of Venice, which is self-sustaining. To conclude, in seminar, we will speak of the flooding in Venice in more detail. We will analyze socio-cultural aspects of the proposed solutions and discuss the repercussions of various solutions on the people and environment connected to Venice. We look forward to seeing you there.